let's talk about parent functions and then some functions that have some shifts and stretches and movement in them. So let's start with the parent function for quadratic. So f of x equals x squared. That means if you put 0 in for x here and you square it, you get 0. So that's a point on this graph. You have 1, 1, so that point is a point on the graph, because if you put 1 in here and you square it, you get 1 for y. And then you have 2, 4. You also have negative 1, 1, and negative 2, 4. So this is called the parent function for quadratic. This is the most basic quadratic formula. So then let's consider this over here, which has a little action on it. So you'll notice there's a little more to it than just x squared. So notice a couple things. First of all, we have this number out front. We have a x minus 4 is being squared, and then we have plus 3. So the way we're going to approach this is that if it's minus 4, that means the vertex, instead of being here, is shifted to the right 4 and then up 3 because of that 3. So the vertex is not here, it's to the right 4 and up 3. So if you have minus 4, it's shifted to the right. If you have plus 4, it's shifted to the left. It would have been over here if it were x plus 4. The fact that it's plus 3 means that it goes up 3. So the negative 4 and plus 3 means it goes to the right 4 and up 3, and that's going to be the vertex. Now you also notice that this is thinner than this. And this is thinner because this number here, this a term. So if this a term is positive, it is opening upward. If it had been negative, it would have been a frown face. It would have been opening downward. And the fact that it's a 2 means that it's going to be thinner. So if this number is a number greater than 1, or let's say the absolute value of this is greater than 1, then it's going to be thinner. If it had been a fraction between 0 and 1, then it would be thicker. So they call this a vertical stretch. So if you have a number that's, the absolute value of this number is greater than 1, then it's as if we took this and we stretched it vertically. If this was made out of licorice or something like that, a Twizzler, if you will, then you could stretch it vertically and it would look thinner because of this. If this number were a fraction between 0 and 1, then it would be a compression. It would be as if you took this and you compressed it vertically, so it would force this to actually be wider. So we got to pay attention to that. So here's a little summary of all that. So here's the general formula. Of course, the vertex is the HK value. The A is either a stretch, a vertical stretch, or a compression. The K value is a vertical shift. If it's plus 3, it's up. If it's minus 3, it's down. And then we talked about the horizontal shift for H. If this is minus 4, then it's going to the right. If it's plus 4, it's going to the left. So this is a little bit of a summary on changes that can happen. Shifts and reflections and compressions and stretches and all that kind of stuff. We call it, I didn't mention here, but if the A term is negative, I didn't mention it in the summary. If the A term is negative, that's called a reflection over the x-axis. So that's how that would have affected the equation. So if this had been negative up here, it would be opening downward, and that's called a reflection over the x-axis. So there you go. So there's a little summary of a lot of the things that can happen with parent functions and functions that are based on that.